So guys, let's look at this question. It's a different one. All of these questions, they are from past papers. Please make sure that you don't forget to hit the subscribe button. So the given part, remember, in trigonometry, given part, it's very important. So now if you look at your given part, they are saying ED is a diameter, and now you have to remember that by diameter we're referring to hypotenuse. In our sense, we're referring to hypotenuse. So if you have this triangle here, and if this is your hypotenuse, you know that the angle that is opposite to the hypotenuse has to be 90 degrees. So now that's the same idea here. If they're saying ED, so ED is the one highlighted in red, it's a diameter. So what we know is that the angle that is opposite to this diameter is 90 degrees. So that means this will be your 90 degrees. So now what you can say on the side when you take in notes or when you are analyzing, you can say B3 plus B2 is equal to 90 degrees. So now what will be your reason? Your reason will be angle in semicircle. So now that's the first part. And they are saying with center O. So now if you know that you have center, you need to remember theorems that involve center, and you also need to remember the radius, that if the radius are equal, they form an isosceles triangle. So now let's highlight those radius that are equal, that radii that are equal. So now are you aware that OD is a radii? OD is a radii and OB is a radii. So let's highlight them. So OB equal OD. So now you check if OD is equal to OB, that means triangle OBD become an isosceles triangle. And if it is an isosceles triangle, we can say this angle is equal to that angle, or we can say D1 equal B3. The reason will be angles opposite equal radii. So now we don't have only these two radii. This radii, we have another radius. So another radius is OE. Look at OE is the same thing. So that means OE is equal to OB. Can you see that in triangle BEO? This one, BEO, this triangle, are you aware that it is an isosceles triangle? So if these two sides are equal, then the base angles have to be equal. So if the base angles are equal, that means B2 will also be x, because E is x, then B2 will also be x. And then what will be your reason? Your reason will be angles opposite equal radii, or equal sides. So now you check ED. Okay, the given part is ED is extended to C. We can see that part. Okay, they're saying CA is a tangent. So remember I said if they talk about the tangent, we need two pens. So now I said the first pen, you place it at the point of contact of the tangent, where that line touches the circle. So we can see that it touches the circle at B. So that's where we'll put our first pen. And then where will we put our second pen? We will put our second pen in such a way that we form a chord. So now we can either put it here. So notice that if you put it here, you have a chord. And then what is the angle that is between this chord and the tangent? Obvious, that angle has to be B4. So now where are the pens going? Remember, they can't come here. They have to stop at the circumference. So the pens will go all the way to E. But one thing about E, we know the value of E, or we know it is represented by the variable X. So now if we are saying B4 is equal to E and E is X, so what will be B4? Thank you. B4 will be X. And then what will be your reason? Your reason will be Tancourt theorem. So now let's look. Remember we said this is our point of contact and that's our first chord. The angle between the tangent and the chord was B4. Let's see if we put our chord to be at E. So now what is the direction of the pens? Or firstly, what is the angle between the tangent and the chord that you made with your pens? So that angle is B1. Let me put 3 or 4. So now B1, what is the direction of the pens? Remember, they can't come to this O, they have to stop at the circumference. So they will stop at D. So that means B1 is equal to D1. So that's what we know we can write for there. And you don't have to forget that D1 is also equal to B3. That will be important in as we solve these problems. So now another information is that BD is parallel to AO. So now let's go ahead and highlight the parallel lines. So they are saying BD here is BD is parallel to AO. So now if you look at those parallel lines, can you draw a F in the same direction? Remember, if this is your F, that basically means this angle will be equal to that angle. And then even if you draw your Z, remember your Z can be in two directions. This angle will be equal to that angle. Even your F, it can be in another direction. That means this one will be equal to that one. So now take this figure that we have here, take it and put it here. Can you identify these angles that are shaded? Yes. So the first angle will be B4 equal A. So now you check. B4 is X. If B4 is X, what will be A? Therefore, A will also be X. Do you have a reason? Yes, the reason is corresponding angles because of the parallel lines. So now let's look at another one. Let's look at this F. We are saying this angle is equal to that angle. So now take the same F and put it here. Can you identify this angle? Yes, it's going to be D2. So now D2 is going to be equal to which angle? Can you identify this one here on the diagram? So that will be O1 plus O2. So you see we have so many information, so many equal angles. So I don't think attempting questions will be difficult. So now if you check again, let's look at Z. So can you draw your Z? Obviously your Z will be, if you take this Z, this angle will be equal to that angle. So now if you take this Z and put it there, can you identify this angle there? Yes, it will be B3. And then can you identify this one? Yes, it will be O2. So those two angles are equal because of alternate angles. So now can you see Z? Let's look at Z. This one, this Z, can you identify this angle? It's not possible to draw that Z. So that means this is all the information that we have. Can you see angles in the same segment? I don't see any. Can you see exterior angle of a triangle? Yes, you can see it. It has to be here. So such information is important. And do you remember that theorem that says line torn from center bisect the chord? So it bisect which chord? Chord BE. So that means B1 here will be 90 degrees. Or you can use the F in that direction. So if we use this F, can you see that this angle which is here is 90 degrees. If that's 90 degrees, obviously that one down there also has to be 90 degrees. The reason will be corresponding angles. Or you can use that theorem that says line drawn from center bisect the chord. So guys, believe me, this information here, I think we have solved all these questions with this information. So now let's go ahead and try to attempt the question. So the first question, is give with reasons 3 other angles that are equal to x. So now let's go to our sketch. We said, let's look at the first one. We said B2 is x. Did we have a reason? We said B2 is equal to E is equal to x. Then what will be our reason? Our reason will be angles opposite equal radii. Or remember, as I said, you can say equal sides. It's not a problem. So now, and again, can you see B4? We put x on B4. So we are going to say B4 is equal to which angle? Is equal to E. And both of them, they are equal to x. Then what's the reason? Do you remember the reason? The reason was tan chord theorem. The angle between the tangent and the chord is B4. Then what is the direction? The direction is to E. So that means the reason will be tan chord theorem. So we have 2. We are left with the last one. And now let's look at A here. Can you see A? We said A is x. And how did we get that? Because we said B4 is equal to A is equal to x. Then what was our reason? It was corresponding angles equal. Why? Because BD is parallel to AO. So that was the easiest 3 marks. Giving reasons with reasons 3 other angles equal to x. So that was 8.1. So now let's see 8.2, guys. With the information that we have here, I don't think there's any question that will be difficult for us. So now the second question says express CBE in terms of x. So this is CBE. So now let's go ahead and look at CBE. This is C, and then this is B, and then that's E. Can you see that they want this angle? So this is C, this is B, and then that's E. They are excluding B1. So can you see that B2 and B3, they are equal to 90. So this angle here is 90. Can you see that? So that's 90. And then what's that one? That's x. So now C, B, E will be 90 degrees from here. And then that x, that side. So CBE will be 90 degrees plus x. And then you get your 2 marks. So now 8.3.1. So 8.3.1 says prove that triangle CBD is similar to triangle CEB. So now to prove similar triangles, this is the idea. Let me put it here. The first thing that you do, you introduce your triangles. So we will say in triangle CBD. We're not calculating CBD, we just take it from the question. So it's triangle CBE and triangle CEB. And I want you to look at this part. What you do is you look at the triangles. We're going to draw triangle CBE on the side. So let's go and look at CBE. So this is CBD. So this is C, and then this is B, and then this is B, and then that's D. So I want us to draw that triangle on the side. We can draw it here. So this is our triangle C, B, this is D, and then this is B. That's B4. If you look at it, so that's B4, which is X, and then that is D2. So that is our triangle CBD, triangle CBD. So now let's go ahead and draw the second triangle from the question, which is CEB. So this is C, and then this is E, and then that's B. So we have this triangle, the bigger one. That's something like this. So this is C, and then this is CEB, and then this is E, and then that's B. So now if you check with this one, which B are they talking about? They're talking about this whole B. Can you see that it's highlighted? We found it in the previous question that it is 90 plus X. So that means we have 90 degrees plus X there. So now what is E? With E, we know the value of E, it's X. So now, once you have these triangles, you just go into to look for the similarity. So in triangle CBD and triangle CEB, I don't know if it was CEB or what. Yeah, it was CBE. So we are going to look for similarities. We need 3 conditions. So first condition, what do you notice about these two triangles? There's something that is the same. The first thing, look at the C's. We have C and then we have C. So you can say angle C is common. That's our first condition. Or some people prefer writing C is equals to C, and then they will say common angle. That's still fine. So now number 2, compare these triangles. What do you notice about B4 and E? Can you see that both of them are equal to X? So we can just say B4 is equals to E is equals to X. Remember, we did prove it in the previous question. So we can just say proved, or you can write the reason again if you want. The reason, you remember, it was Tan-Cot theorem. You said B4 equal X. That's Tan-Cot theorem, or you can just say proved. So the last condition is this one, with D2. Remember, we're done with C and C, and then we're done with X and X. So we're left with these 2 angles. So we can say angle D2 is equal to angle CBE. Reason will be third angle, or sum of angles of triangle. So you will decide which one you prefer. So now, how many conditions do we have? We have 3. So therefore, we write our conclusion. Therefore, triangle CBD is similar to triangle CEB. Why are you saying that? Look at the first condition. For similarity, it will always be angle, angle, angle. So now you have proved that triangle CBD is similar to triangle CEB. Now you go and get your marks. What was the mark? The mark was 2. It was 2. That's stingy. So let's look at 8.3.2. So I will just write it here. 8.3.2. That's saying prove that 2EF dot CB is equals to CE dot BD. So now, such questions, they always follow similarity. So that basically means you need to work with similarity to be able to have an idea of how they got such answers. So now let's divide these 2 triangles proportionally, but by looking at the similarity. So we are going to say CB over, so it's CB over CE equal BD over EB equal CD over CB. So now what will be the reason? The reason will be similar triangles. So now many people, they can get this step right, but after this step they just get confused. So I'm going to show you how do you do it. You look at the common CB. Can you see CB there? So we're going to use, you see we have CB, no problem, and you also have CB there, no problem. Can you see CE? Here is CE. So do you have CE here? Yes, here is CE. So that means this one, you're going to take it. There's no chance because it contains two lengths that are there in what is required to prove. So we will have CB over CE. So that means we take in that one. We don't have a chance. So now we're going to compare between the two. Are you aware we have BD and then we don't have BD here? So that means, but with CB we have CB. So CB, here is CB, and then CB, that's the second CB. So we're not going to take it. At least if we had CB squared, we're going to know that we're going to take the two. So we can go with that one with BD because we are looking for BD. So we have BD over EB. Yes. So let's now cross multiply. If you cross multiply, you will have CE dot BD equal CB dot EB. So now if you look at this thing, you become positive. Why am I saying that? It's because if you look at this part, it's the same part that's there. So that means we are close. And then if you look at this part, is that part there. So now the only part that is foreign, it's EB. Believe me, that part that is foreign, let's go and look at it. You'll notice something here. Let's look at this part. Where is CB? Here is EB. EB. Remember what I said. According to that, the first theorem. The first theorem says line drawn from center is perpendicular to the chord and bisect. Let's look at the line. This is the line drawn from center, bisect the chord, or perpendicular is the perpendicular bisector of the chord. So what does that mean? That means this one is equal to that one. So that means what we can say is BF. So here BF is equals to FE. Why are we saying that? The reason is line drawn from center, bisect the chord. So if this piece BF is equal to FE, what does that mean about EB? So that means EB, so EB is equals to twice FE. I don't know if you can see that. So EB is equals to twice FE. So now since we know that the value of EB, what can you do with it? Is equals to twice FE. So we can take the value and put it there. Therefore, if you take the value and put it there, you have CE dot BD is equal to CB dot. We are removing EB because EB is twice EF. So that will be twice EF. And then you can just change to get the exact thing on the equation. So if we change, you have 2 EF dot CB equal CE dot BD. So that's how you get your proof. So we have proved that 2EF dot CB equals CE dot BD. So we have to attempt the last equation. So I think we'll attempt the last question. in the next video. So don't forget to hit the subscribe button. Keep on sharing the videos. I want to make sure that a greater number of learners are helped through this the discussions of the problem solving. So welcome back. So guys, in the previous video, this was our last question. What the last question was to show that 2EF over CE is equals to AO over AC. So now if you look at this thing, it's similar to something. It's similar to that part. Why am I saying that? Because we have 2 and then we have EF, that's the part, and then we have CE, that's the part. The only thing that we don't have, it's CB and BD. So that means for us to be able to get this, to prove that 2EF over CE equal AO over AC, we're gonna have to use this one and manipulate it. So now let's go ahead and manipulate it. So let's say in the previous question we proved that 2EF dot CB equals CE dot BD. So now you ask yourself questions. Can you move from this thing to get that one? Obviously, you have to divide. Now you check. Are you aware you have CE as a denominator there? So that means even here, you must have CE as a denominator. What you do on the left, you do on the right. So now check. We can get 2EF over CE, but the problem now is CB. So that means you have to multiply by CB. What you do on the left, you do on the right. So now are you aware if you remove the CBs, what do you have? You have 2EF over CE is equals to CE gone. So you have BD over CB. At least we are getting somewhere. So now we have to prove that this thing is the same as that thing. So can we prove it? Let's go to the sketch and see something. Observe. I know the sketch is untidy, but no problem. So now look at AO. Okay, I'm going to, okay, no, let me not read one. That is AO over OC. I'm going to highlight AO over OC. I want you to see something. That's AO over OC. Let me redraw that. So we have something that's like this. So that is your C, that's your B, that's D, and that's A, that's O. I want you to see something. Here, what can you say about the small triangle and the big triangle? First condition, this angle is common. It's common in the small triangle, which is CBD, and the big triangle, we still have C, which is AO. So, are you aware that C is common? No problem. And notice something. What can you say about this angle and that angle? Yes, they're equal. Reason being corresponding angles because of the parallel lines. So that means that angle is also equal to that angle. Are you aware on the other side it's going to be the same thing? And then the reason will still be the same, corresponding angles. So now, what do you say about the two triangles? So, triangle BCD is similar to triangle ACO. I don't know if you can see that. The reason will be angle, angle, angle. How many conditions do we have? We have 3. That's the first one. That's the first one. That's the second one. That's the third one. So these two triangles are similar. And now it's true to do this, check what they did. If you look at this thing, they're saying AO over AC. Let's go ahead and do that. So this is AO over AC. So this is AO over what? Over AC. So now, if they're saying AO over AC, what are we going to say in the small triangle? Obviously, we have to say BD over BC. So therefore, the two triangles are similar. Therefore, 2EF over CE is equal to, we have BD over CB. So this is BD there over CB there. So that means for the big triangle, we have to follow the same pattern. It's going to be AO over what? Over AC. So didn't you prove that? So we're done proving that. So I want us to try questions whereby we have two circles. So I have one question that I want us to try where we have two circles, so that we leave no stone unturned. So this is your snake. Here you'll just play around. I'm just going through this question so that you are familiar with them. So complete the following statements so that they are true. The angle between the tangent and the chord is equal to angle in alternate segment. So that one we've been talking about it. Remember when we want to find the angle that is equal to the angle in the alternate segment in the tan chord theorem, whereby we use two pens. So it's the same case. So they are saying opposite angles of a cyclic chord are, if they're saying opposite angles of a cyclic chord and they put 3 dots, someone was going to say they add up to 180 degrees. But if they're saying are, you need to use the word supplementary. So they are supplementary. So that was just us snaking on that question. So here is the real question. Remember, we're going to analyze, we're not going to go through the questions. So guys, make sure that when you are alone and analyzing, make sure that you don't waste time. You just analyze your things fast. So now they are saying in the diagram below, two circles have a common tangent. See, they're saying two circles, they have a common tangent. So now, where is that common tangent? Obviously, it has to be in between the circles. So now, are you aware that this BT, that's our common tangent? This line here, it is our common tangent. And when we see tangent, the pens. So now, where is the point of contact of this tangent? Here is the point of contact. So which one are we starting with? Are we starting with the bigger circle or the smaller circle? We can start with the small, no problem. So now, where do you put the second pen? You put the second pen in such a way that you have a chord. So now, if you put it here on P, you still have a chord. So now, what is the angle that is between the tangent and the chord that we made with our pens? So what is the angle that is between the tangent and the chord? So this angle, it is A3. So that's your A3. So now what is the direction of the pens? They are going to N. So what does that mean? That means that A3 is equal to N. So now we'll just put, or we can highlight it there. A3 is equal to N. Reason will be tan chord theorem. So that's your reason, tan chord theorem. So now remember, you can use your tangent in both sides. So now let's change side. This was our chord. So now if you change and put the pen here, you still have a chord. So now what is the angle that is between the tangent being this line, and the chord is the line that we have with the pens? So now what is behind, or the angle that is between the tangent and the chord? Thank you. It's going to be A5. So now with your pens, the angle between the tangent and the chord, that this is the chord and this is the tangent. So the angle between there is A5. So now what is the direction of the pens? So they're following the lines up until P2. Can you see there? Up until P2. So that means, and remember, your pens must stop at the circumference. So they move up until P2. So now that means the angle that is equal to N5, A5, it's P2. So we do the same thing. Remember we said this tangent is common, so we had to start with the smaller circle. Now we go into the bigger circle. The bigger circle, we're still going to use pens. Point of contact, here is the point of contact. So where do you put the pen in such a way that you have a chord? Obviously you can put it here. So now the angle between the tangent and the chord is A6. So now what is the direction of the pens? The direction of the pens, they are going to R2. So that means A6 is equal to R2. So you do have the reason? Yes, the reason is tan-chord theorem. So now I want us to write down all the information. We said A3 equal to N, and then we said A5 equal P2. The reason is still the same. I'll just put those to show that the reason is still tan-chord theorem. So now again we said, using the pens, we said that A6 is equal to R2. A6 is equal to R2. So that means A6 equal R2. So the reason is still the same, tan-chord theorem. So now remember I said we can change our chords. This is the first chord. Now what will be the second chord? The second chord will be in that direction. So now what is the angle between the tangent and the chord? So that angle is this one. That's A2. So now what is the direction of the pens? Where are they going? So they are going to Q. I don't know if you can see that. Okay, maybe I can change it. So this is the pens, the point of contact and the chord. Where are the pens going? They are going to that Q there. So that means we know that A2, we can highlight it. A2 is equal to Q, but Q equal to what? 40 degrees. Then what's the reason? Tan-chord theorem. So now we know that A2 will be 40 degrees. So now I'm seeing something here. Look at A2 and look at A5. What can you see there? A2 and A5. Remember that one. Remember that reason. A2 and A5 are vertically opposite angles. So that means A2 is equal to A5. But we know that A2 is 40. So what will be A5? A5 will also be 40 degrees. Then what will be the reason? It will be vertically opposite angles. So now you know that even this one, it's 40 degrees. And if you go back, we said something about N5, A5. We said that A5 equal P2 here. We said A5 equal P2, but now we know that A5 is 40. So what will be P2? Therefore, your P2 will be 40 degrees. Simply because P2 is equal to A5 and A5 is 40, so that means P2 will also be 40. So now we know that the value there, it's 40 degrees. So now that the last thing that we didn't do, remember they told us that PT, here is that part, PT is a tangent to the smaller circle, so we can use the pens. So where is the point of contact? There is PT. The point of contact is at P. So we need to place this pen in such a way that we have a chord. So if you put it here, are you aware we have a chord? So now what is the angle between the tangent and the chord? That is this angle. I will just make some design there to show that those two are equal. So now what is the direction of the pens? The pens are going to A4. I don't know if you can see it. Remember, we are focusing on the small circle, so it must be at the circumference of the small circle. So here is our A4. We can also highlight the angle P3 equal angle A4. And then what will be the reason? The reason will be tan chord theorem. No problem. And then remember I said you can take your tangent two directions. If you take it this way, it says it take you to A4. That means P3 equal A4. But if this is your chord, what is the angle between the tangent and the chord? So that angle, it's P1. So what is the direction of the pens? The direction of the pens, they're going to your N. So that means your P1 equal N. The reason will be tan chord. So now just imagine you have this information. So are the questions going to be difficult? I doubt, because you have all the answers in your sketch. So now the first question says, determine with reasons 3 other angles equal to 40 degrees. So that is 17.2.1. That's the numbering. So 17.2.1, determine with reasons 3 other angles equal to 40 degrees. So now if you check, we have 40 degrees in our sketch. The first one was A2. We said A2. Okay, not before A2. Yeah, we said A2 is equal to Q is equal to 40 degrees. What was our reason? We said A2 equal Q. So the reason was tan chord theorem. So that's the first one. They said they want 3 angles. And then remember we said if you look at A2 and A5, they are vertically opposite angles. So that means A5 equal A2 equal 40 degrees. Then the reason will be vertically opposite angles. So now the last angle, do you see that 40 there? So because we said A5 equal P2 equal 40 degrees. What was our reason? Our reason was tan chord theorem. So you have 4, 6, 3 angles that are equal to 40 degrees. The first angle is A2, the second angle is Q, and the third angle is P2. So those are the 3 angles that are equal to 40 degrees. So if you're not fine with that, you can comment in the section. If I made mistakes, you can comment in the section, in the comment section. So 17.2.2, they're saying if P1 is equal to A4, so we go okay, P1 equal to A4, no problem. They say prove that PTRN is a parallelogram. So this is PTRN, it's a parallelogram. So now let's check at the part information that they give us. They're saying, I want you to go through the information. They're saying P1 is equal to A4. Let's go to the sketch and look at P1 and A4. This is P1 and that's A4. So if you look at those angles and then you think about this thing, what is the difference between the two? No difference. So that means, and when do you use this thing? When you know that the lines are parallel. So now what we can say is we can say line PT is parallel to line RN. So why are we saying line PT is parallel to line RN? Because if we look at P1 and A4, they are alternate angles and they are equal. So we can say alternate angles equal. That's why we are saying PT is parallel to Rn. So now another thing that we can look at, remember the properties of a parallelogram. Properties of parallelogram says that opposite angles are equal. So now can we work our magic and prove that the opposite angles are equal? Yes, we can move around with some things here. Like, okay, if we check, let's look at this part. If these two lines are parallel, like PT, if PT and NR are parallel, are you aware that we can prove something here? We can either prove that angle T is equal to angle N. Why is it possible for us to prove that? Simply because we know that if the opposite angles are equal, then the figure has to be a parallelogram. So now let's go ahead and try to prove that we can use the river method. Let's go ahead and prove that T1 plus T2 is equal to angle N. So now let's go ahead and give me an angle that is equal to angle N. Give me an angle that is equal to angle T1 plus T2. So now if we check, since we know that these two are parallel, are you aware that if these two lines are parallel, can you see that F there? So that means T1 and T2 will be equal to R2. So now with river method, do you have a reason? Yes, we have a reason. The reason will be corresponding angles.